Now that you have some background information about polynomials and you've practiced adding and subtracting, which again is just combining like terms, we're going to talk about multiplying polynomials in lesson 2 of this unit 7. And we're going to break this up over a couple of days. So our focus is going to be what I typically call 2x2s, which basically means starting off with a focus on binomial multiplied by binomial. So you can see here I have two terms in this parentheses that's considered a binomial, the x plus 2 for example, and I'm multiplying that, see how they're right up against each other, by another binomial x plus 5. Okay, and so I'm going to walk you through essentially 3 forms, although it's going to look like 4. 3 forms or different methods that you can do this. We're going to see it worked with the distributive property, and you're going to realize it's really nothing more than just the original type of distribution that you're used to working with. And then you're also going to see it with a couple of other methods that help organize the information. Sometimes that's helpful. I do not have a preferred method for you to use, although I typically, in these cases, with it's a binomial times a binomial, I tend to lean towards the first one, which is what we like to call FOIL. And FOIL is one of those things that just sticks with you. Even if you get home tonight and you ask your parents, you're probably going to be like, oh, yeah, I kind of remember FOIL. It's just one of those things that always kind of sticks in your head, okay? But first, we're going to just look at this from the perspective of the distributive property, because that's really all it is, okay? So when I want to multiply, two things times something in a parentheses, typically when we had just one thing outside the parentheses, we'd make sure we distribute, like on number 1 here. If I have negative b and we distribute, I want to multiply it by this group of things, I just make sure that I distribute it. Well, the same thing is going to happen here, except you're going to make sure that each term in this first parentheses has the opportunity of being distributed into the second parentheses. So, for example, we might start with the x here. And so for a moment, I'm not going to worry about anything else, but I'm going to focus on that x. I'm going to say, okay, to multiply this, I've got to take this x, and I've got to make sure that it gets distributed into the second parentheses. And that's what you're seeing right here. We're taking that x, the very first term, and we're distributing it into the x plus 5. And then you'll multiply x times x when you distribute that, and that'll give you x squared. And then you'll also do x times the 5, which is just 5x. So distributing that first term into that binomial, the second one, and distributing it gives you x squared plus 5x. If we were just having if that's all we had to do here, then we would have done, x times x and x times 5, right? The difference is that since there is more than one term, once you're finished distributing that first term, you go on to the second term and you do it all over again. And so in this case, we also have the positive 2, this constant, and we want to make sure that it has the opportunity of being distributed. So then we would also then do 2 times that x plus 5. And I'd make sure I do 2 times x and 2 times 5, and you'd get 2x, and then here in the 2 times 5 you get 10. And you would get that set of products. So if it had just been this problem, this would have been our result, right? So these were the results for distributing the x, and then this is the result for distributing the 2. And then typically, right, on these that have binomial times binomial, a lot of times we end up with, we'll always end up with 4 terms, but a lot of times then a couple of those terms end up being like terms that we can then combine, right? So I have x squared, I have a positive 5x, I have a 2x and a 10, but these are like terms, so then we can combine them. So this is the resulting product. The result of x plus 2 times x plus 5 is x squared plus 7x plus 10, okay? So let's go ahead and try it. Again, if you need a little bit of practice just on distribution by itself, then you can start with a problem like number 1, and you can say, okay, if I only had one thing, let's review how we would distribute that single term there. I would make sure that I do that negative b times the first term, which is also a b, and then that I also would do that negative b times that negative 3, okay? And so When we do these first two, a negative times a positive stays negative, and b times b is b squared, or b to the second power. And in this next one, negative times a negative is a positive. So negative times a negative becomes a positive, and then b times 3 is just 3b. So that would be the result there if you wanted to just practice a single term being distributed. But really the idea is to now expand this into a problem like number 2, where we have a binomial being distributed into the second parentheses, which is also a binomial. So if we do this one, same thing. We're going to do what we did here. We're just going to take one at a time. So I'll start with the x, and I'll start off by saying, okay, what we're going to do here is we're going to take this x and we're going to distribute it to that second parentheses. So x is going to get multiplied by 2x plus 1. Okay? But then in addition to that, we're also going to take the 2 and do the same. So take this 2 and distribute it. And so we're also going to do the positive 2 times 2x plus 1. All right, so for a moment we ignore this and we kind of do this problem, and that's this guy. And then we go back and we do it again with the next term, and we distribute it, and we get that. Okay? And then we go ahead and do the math here. So if I were just to distribute the x, x times 2x is 2x to the second power. And x times 1 is just 1x. So you can write 1x or just an x by itself. The second one, 2 times 2x, that's 4x. And then 2 times 1 is just 2. And like I said, if you're doing a 2 by 2, which is a binomial times a binomial, you should end up with 1, 2, 3, 4 products. But a lot of times, not always, guys, but a lot of times a couple of those are like terms, and then you can and should combine those together. So when we do that here, the 2x squared stays, but then I have x plus 4x, so that's a total of 5x's, and then the positive 2. And just be careful. Remember, when we're multiplying, our exponent increases. So x times x is x squared. But when we're combining, it's our coefficient that keeps track. So x plus 4x is 5x. It's not an x squared anymore. When you're just combining like terms, the type of term, it doesn't change. You should not change the power on that. This is your resulting product. Okay, so go ahead and pause the video and try number 3 here. Go ahead and try number 3. Give it a shot, and let's see, and then you can check your answer and see if you got it right. All right, so check your work and see if this worked out well. Distributed, first the 3y gets distributed into that second parentheses. So we do 3y times 2y plus 5, and when you distribute that, you get 6y squared plus 15y. And then you go back and grab the negative 4, and you do the same. Negative 4 times the 2y plus 5, that's going to give us a negative 8y and a negative 20. And you do have a couple of like terms here. Positive 15y minus 8 is 7y's. So this is our result, or our product, when we work that out. Okay, now flip it over. What I'm about to show you is not any different. It's really just an acronym to remember what we just did. And it's a pretty famous acronym, but the work that we're going to do is exactly the same. So when it's all said and done, if you realize, when we distributed the first term, we made sure basically we multiplied the first two things together and then the outer or outside terms together. So by distributing that x, when I did that here in the blue, right, I did the first two terms and then the outer two terms. That was this result right here. And then I did the inside terms. There's my 2 times 2x and my last two terms. So when I talk about FOIL, and you will hear me say that a lot, that is the only, I'm just referencing this acronym that is meant to remind you what those steps for distribution are in a little bit of a faster way, if you will. Okay, the work is exactly the same. What we're still doing is technically still just distributing. Again, it's just an acronym to remind you. So anytime I see a 2 by 2, I'm like, oh, you gotta FOIL that if we're being asked to multiply it. And that reminds me, oh, I've got to make sure I multiply the first two terms together. So x times x is x squared. the outside, the outer terms, which is the x times the negative 3. There's my negative 3x. And then do the inner terms together, the ones on the inside, so 2 times x is 2x. And then the last term in each parenthesis, so the 2 and the negative 3, 2 times negative 3 is negative 6. So I arrived at the same exact 4 products that I would have if I would have thought about this in terms of, oh, I'll distribute the x, well, that's x times x, and that's x times negative 3. And then I'll go back and distribute the 2. Well, that would have been 2 times x and 2 times negative 3. So you get exactly the same 4 products, the first, the outer, the inner, the last, as if you just thought about it as distributing the x and distributing the 2. Whichever one fits in your brain better is totally fine. Just make sure you combine any like terms there at the end, so you write your answer in a nice, simplified standard form. Notice we're also putting them in standard, putting them from high to low. We learned about that in the last lesson, so that our degree or our exponents are going from the highest down to the lowest. Okay, so give it a shot here on number 6, maybe using the FOIL, and you kind of get used to seeing that. I always just write out my FOIL there. So if we do it with FOIL here, the first 2 terms are the z times the z. So z times z is z to the 2nd power. Outers, z times 2, which is just 2z. And then our inner terms, 3 times z is 3z. And then the last 2 terms, which is the 3 times the 2. 3 times 2 is 6. In this one, it's similar, but because the signs were different, these guys actually add up instead of subtract. So I end up with z squared. In the middle, I end up with a total of 5 z's, and I still have that positive 6. Okay? So that's the FOIL method. And here's the deal. A lot of times when we work these, especially once we get into quadratics, they are going to look like 5, 6, and 7. But they really work with any type of binomial, even if they have, for example, 2 variables or higher degrees or higher exponents. So let's try a couple of those. Okay, and then we'll talk about the next method after that. So let's kind of tackle numbers. We'll look at this and say, okay, well, it's a 2 by 2, so we can still use FOIL here. And if we multiply the first 2 terms, that's a negative q or negative 1q times 2q. So negative times 2 is a negative 2, and q times q is q to the 2nd power. When I do my outer terms, these are not the same variable. In multiplication, that is okay. In multiplication, I can still multiply them. I'm just going to leave those letters next to each other. So again, my coefficients are a negative 1 and 3. So a negative 1 times 3 is a negative 3. And then q times r, well, they're not the same, so I'm just going to leave them next to each other. So my middle term is a negative 3qr, or rq. Okay. When I do my middle terms, or my inner terms, okay, negative 1 times 2 is negative 2. And again, I have a r times q, which is just qr, or rq, same thing. And then when I do my last terms, negative 1 times 3 is negative 3, and r times r is r squared. Okay, and so even though we had these letters, we end up still having a couple of like terms here in the middle. So we've got a negative 2q squared. These two are the same type, so negative 3 and negative 2 combine to negative 5 of the qr's. And then we still have that negative 3r squared. When we have more than one letter, I just want to remind you that we don't worry about standard form. So there's no right or wrong order here. Typically, we kind of follow alphabetical order is kind of the go-to, but there's no right or wrong. If they have more than one variable, standard form kind of just goes out the window, so don't worry about order. Okay? All right, let's try one more like this with these higher powers. This will remind us, or we'll have to kind of dig back a little bit on this one, how to handle this when we're dealing with exponents, right? And kind of what those exponents rules are, if that sounds familiar. So let's try this one. When we do the first 2 terms, I'm going to do 4n squared times 3n squared. Well, 4 times 3 is 12. And then n squared times n squared, I'm going to have to remember the rules for this, right? When we're multiplying like bases, I add those exponents. So n squared times n squared is really n now to the 4th. Okay? So 4 times 3 is 12. N squared times n squared is n to the fourth because we add those exponents. Let's do the outer terms. 4n squared times 4. Well, 4 times 4 is 16. And then we still have that n squared. This guy didn't have any n's, so it's going to stay n squared. When we do the inner terms, negative 1 times 3 is negative 3. And then again, all I have is an n squared. That stays the same. There's no other n term that would change that. And when we do the last, negative 1 times 4 is just a negative 4. And then we do have a couple of like terms right in here. So we can combine those. So this first one will stay 12n to the fourth. But then these are like terms, so 16 minus 3 is 13 of the n squareds. And then we still have the constant of negative 4. So that would be our resulting product. Okay? All right, friends. So that is the first and primary method, distributing, which sometimes when it's a 2 by 2, a lot of times we say FOIL. We make sure that basically every term in the first parentheses needs to have the opportunity to be multiplied with every term in the second parentheses. So FOIL is just a way of organizing that. Okay, I'm going to show you a different method for exactly the same thing. Some people love it. Some people say, you know what, I don't need that. It's a really nice way if this kind of gets a little disorganized for you and you're more of a visual person. This might help. This is called the box method, sometimes also known as the area model. And it's pretty simple. You just basically make a box, and then with enough of like sections in it, if this is a 2 by 2, then we need a 2 by 2. And then you just use it to kind of organize your answers. So if I have 2x minus 3 and I have two terms, then I basically make two columns, one for each one. And x plus 5, I make 2 rows for each one. One of these boxes, I put the result of those dimensions. If you thought of this as like the area, if this was x by 2x, this would be 2x squared, right? So it's like you're multiplying the values. 5 times 2x is 10x, x times negative 3 is negative 3x, and then 15 times negative 3 is negative 15. You still end up with 1, 2, 3, 4 products. It's the same products you get with first, outer, inner, last, or by distribution. And you'll still want to recognize that you have a couple of like terms that you can then combine and before you write your result. Okay, and actually there's a typo on here because that 3 should be negative. This is a typo right here. Let's fix that. So here, this should be really 7x's. Yeah, it's just a typo. All right, so the answer here should be 2x squared, positive 7x's, and then the negative 15, okay? Because that should be a negative. But anyway, you'd combine your like terms just like that. So let's practice a little bit of the box method. I laid them out here for you just to make it a little bit easier, but you can always make them fairly easily, if you will, okay? So again, it's a 2 by 2, so I'll make a 2 by 2 type of box, right? It does not matter which one you put across the top or across the side. It does not matter one bit. Okay, so maybe on this one, on number 11, in this particular example, maybe I'll put the x minus 2 across the side here. So it's an x and a negative 2. So this one went there. And then the 4x plus 1, you got a 4x and you have a positive 1. Okay, so you basically label the rows and columns, and then your answers inside are just the product of those. So here, and you can do this in any order. That's kind of one of the nice things about it. Now it really, you can mess this up. You know, if you set it up correctly, it's hard to mess it up, right? As long as you filled in all your boxes, you know you have found all the products. So I could do x times 1 is x. I can say 4x times negative 2 is negative 8x. Negative 2 times 1 is negative 2. And then 4x times x is 4x squared. So there's the 4 products. And then again, you just got to be careful and recognize that a lot of times you'll have a couple of like terms that you can combine. So our final answer here is 4x squared. When you combine 8x, negative 8x, and a positive 1, that's negative 7x. And then we still have the negative 2. So that's our result right there. Okay? So if you like it, run with it. If you don't like it, don't stress it. You know, this is just another option, okay? So you've got 3d squared minus 2 here. Doesn't matter if you put that across or on the side. I might say, okay, I'm going to put 3d squared and the negative 2. That's going to go across the top, and this other term is 2d squared and a 3. Maybe I'll put that across the side there. Okay, as long as I fill in these with the correct products now, all is good. So if I do 3 times 3d squared, that's 9d squared. Okay, 3 times 2 here is 6, and d squared is d to the 4th. Okay, that's a 6, but it doesn't look very much like a 6. Let's try to fix that. Negative 2 times 2 here is negative 4d squared. And then this very last column here is 3 times a negative 2 is a negative 6. And again, we'll recognize, oh, but a couple of these are like terms, so we can combine those. So our final answer is at 6d to the 4th power. These guys combine to positive 5d squared, and then a negative 6. Just like that. Okay? So maybe go ahead and put a pause on this and try number 13. Okay? And then see if you... All right, so check your answer. If you got negative 3j squared, that is correct for the first term. These guys combine, so we end up with 14j in the middle term, and then the negative 8 is your constant, and that comes here to the end. Okay, I want to do one more with you. I want to do number 15 because I do want you to see that sometimes a little something happens. Okay, so let's take a look at number 15. I'm going to start it as usual. I'm going to say, okay, I'm going to put one of these across the top here, maybe 2p squared and the negative 1, and the other one is a 2p squared positive 1. And then we'll start to find these products. So 2p squared times 2p squared, well, 2 times 2 is 4, and p to the second and another p to the second will add those exponents, so that's p to the 4th. 2p squared times a negative 1 just changes the sign to negative. 2p squared. 2p squared times 1 stays 2p squared. And 1 times a negative 1 is a negative 1. Okay, and then I want to recognize, yeah, I have a couple of like terms here in the middle, so I can combine those. So I have originally 4 products here, and when I combine these, though, I want you to notice what happens. You got 2p squared and a negative 2p squared. So those are exact opposites. Instead of adding up to different terms here, what's going to happen? They're going to cancel, right? So they're exact opposites of each other. They're going to zero each other out. So in this case, our result happens to just be the 4p to the 4th, and then the negative 1. And that's the product for number 15. Okay? So that does sometimes happen. The middle terms cancel each other out. 4 is another one like that, if you tried that one on your own. And we're actually going to a little deeper into that, or dive a little deeper is what I meant, before the end of this unit is over. Okay. You've got one last method I'm going to model for you. I'm probably just going to do the first one. I personally love this method, but most kids don't. But I do think that there's something to be said about this, because this is what I love about using this method here and finishing it off. Okay? My big idea that I want to communicate and that I'm going to prove to you right now is that this is something that you've been doing since elementary school. Okay? I want you to let that set in your mind. You've been doing this since elementary. You might be like, no, I didn't, Ms. Sherida. Yes, you did, okay? And I'm going to prove it to you here in a moment. When you're in elementary, I'm not sure what grade, maybe 3rd or 4th grade, you started learning how to multiply larger numbers than just, 4 by 4. So you might have had something like, I'm going to multiply 63 times 12, okay? And you were taught how to do stuff, and sometimes you had these tables or these like minute math that you had to go see how many you could do fast, okay? And when you did this, you learned in elementary that you had to do 2 times 3 and then 2 times 6, right? 2 times 3 is 6, 2 times 6 is 12. And then when you finish multiplying the 2, you would put a placeholder or a 0, and you'd start with a 1, and you'd say, oh, 1 times 3 is 3, and 1 times 6 is 6. And then you'd combine those together, and so your result was the 6, a 5, and a 7. So 756 was our result here. I sure hope I did that right. Let's find out. But you learned how to do this in elementary school. Yeah. and you became pretty much a pro at it. Okay, and I want to explain to you here and demonstrate that what we are doing in this whole lesson, this whole time, these last 24 minutes, is exactly what you did in elementary school. Okay, so you can take any one of these two, write it vertically like you're used to using numbers here, and do exactly what you did when you were still all cute and adorable with a lunchbox and pigtails and, you know, all of that stuff, your Superman backpack, whatever it was, right? You already knew and did this. So let me show you that on, for example, number 17. If I do this times this, I can write these vertically. So r minus 5 multiplied by 2r minus 1. And then I can work this problem exactly like you learned back in the day. So I can say, okay, -1 times -5, that's a positive 5. Okay, and then -1 times r is just a negative r. So I've got a negative r and a positive 5 right there. And then when you're done distributing or doing that -1, we would use a little placeholder, and you're welcome to write one if you want. And then we would start with the next number on the left. And we would say, okay, 2r times -5. Well, 2r times -5 is -10r, and I'm going to write that with my like terms. So there's me skipping this part and making sure I'm just lining up like terms, which is really what you do. When you plug the 0, you're basically lining up your ones place, your tens, your hundreds. Okay, that's why we do that. Well, you're doing exactly the same thing here. You're lining up the like term below the r value. So this is -10r. And then 2r times r is 2r to the second, and so that'll be next to it. And once I've distributed the -1 and the 2r, look, exactly like before. You just drop your line and you combine everything straight down. So this comes down and we end up with a positive 5. -r and -10 is -11r. And this guy comes straight down, doesn't have anybody to combine with, and there's your result. Guys, y'all were doing this when you were in elementary school. It is exactly the same thing. How cool is that? And so that's the third and final kind of method. So you got the FOIL method, which is basically distribution, the box method, or the vertical method. They'll all give you the correct result as long as you multiply it correctly, and you can pick the one you like the best.